Welcome back to Refactoring Paleo Rose, where we're taking a 20-year-old app and modernizing it. My name is Tom. Today we're doing the last step of moving SQLite calls out of the document. There'll still be some SQLite in there in terms of the pointer, but actual SQLite calls where we're reading and writing to the database is moving away. So we have 3 methods left to do. Unfortunately, this turned out to be a much bigger problem than I originally intended. So I was hoping to get things moved quite easily, but it turned out all this code integration was far worse than I originally anticipated. Let's take a look at the first method. The first method is called Discover Tables. What this method does is looks for user-imported data tables. Now, the way it works in the app is that when you import a data table, it will create a unique table inside the database, usually with the file name is the base name. And so we'll attempt to create all the columns and everything for that table. Now, the database itself does not maintain a list of these tables. So the purpose of this function is to go into the database, look at all the tables, and find which ones are these user data sets. So right now, this process is being done by the document. We'll be moving that later on, but right now it actually calls into SQLite. We want to move that functionality out of the document. We can do better in the future, but right now we have what we have, and we need to make this code work. So let's jump to the code and see what I did to fix this. The method is quite simple. So we start with just setting up some basic variables, creating our SQL call. So this is actually just looking for table names from the SQLite master table and pulls out all the table names, but filtering out different tables that I know are there, and I don't want to add to this list. Once we have that, we can prepare our statement, have an if check to make sure that error call or that prepare was okay, remove all the objects in the table, and then do our SQLite step call. Every time we do this step, if it's not a SQLite done, we will jump into here. So if it's not done, we pull out the different names for these tables and then just add it to our table list. If we get an error, we throw and present that error, close out the statement at the end, and then we update that table on the main window controller. So we're not going to fix this right now, but we need to fix all of this. What's the first thing I did? Well, we had all those filters, and those filters made sense inside the SQLite call, but it made the call very, very complicated. What I decided to do instead was just get all the tables and then filter out the ones that I know aren't the ones I'm looking for. So let's start with this data tables function. This is inside the in-memory store. So this is only something that technically applies if we're using SQLite as a backend. We have this data table call, and we come back with a table schema. The table schema is just a form of table representable, so I can do SQLite calls on it, with the table name and some other information on it. And again, it's just mainly to simplify the process of pulling the data out. The SQLite store, of course, we go through the SQLite store, and then we just ask the database for all the table schemas. So again, the query is actually inside the stored values property or function associated with the table schema, which is actually associated with the table representable type. So now we already have all the tables. Then we have the non-data table names, and we just filter those out and return that value. And that gives us the list of table schemas for those items. Fairly straightforward. We call this from the document model. We just ask for data table names. We expect to return a string. We call data tables in the in-memory store, map them to with a name, and just return those values. If we go to the document where we have discover tables, now we've simplified it, at least in terms of the document. Remove all the objects from the tables, ask the document model to give us all the table names, and then update the main window controller. That was fairly straightforward. Next, we have load dataset from DB. In other words, load a dataset from the database. This function is a little bit more complex than it sounds. So a dataset in this application is a type called XR dataset. That dataset contains metadata about dataset you can plot and also contains the data itself. So the database that we use, or the table in the database that we use, is underscore datasets. That underscore datasets table only contains the metadata for the dataset. What table is that from? Is there any SQL predicates in there, and that sort of thing. So it basically describes how to read the data out of a user-supplied data table. But the dataset also has a copy of the data that is specifically for that particular dataset. That's to fully hydrate the dataset. Not only do we have to pull it out of the datasets table, but we also then have to pull the actual data out of the user-supplied tables. This particular function caused me a lot more grief than I expected, again, because of tight integration. So let's go back to the way it was and get an idea of why it's such a problem. Okay, so here we are at load datasets from DB. For the most part, it looks like a standard SQLite process of reading data. So we do the setup. We have a prepare statement with our SQL command in it. We check to see if that throws an error. And you may have, I'm going a little quick, but one thing that, to be clear, is the first thing it does, it just counts how many data sets there are. So it just comes back with a count. And then we're looping through to get the SQLite step to get the count, and that will always be just one at the most. And then we finalize that statement. So we're only getting the count here. We're not actually reading the database, or excuse me, we're not reading the data sets out of the database here. But what we're doing, though, at the end, is we're saying, hey, we have this count. We know there's this many data sets. So we're going to go through and create these dataset objects by passing in the database pointer for a particular index. And then create or add our data sets to our list of data sets. That's kind of a weird pattern, isn't it? We're not even reading the database and creating the data sets. We're actually creating a data set and telling it to read the database. That's not a particularly good pattern to be using. Let's go into this dataset type and try to figure out what's really going on. Wow, so this is fairly complicated here. So we have a number of different ways to init these data sets. Some of these are old and probably aren't being used. Let's just go through. Wow, this is kind of a big and crazy data set class. So we can init with table. Table name is string, column for the document. Why are we even passing the document in? That's kind of a strange thing to do as well. So if you look at this, we're capturing the document, we're getting the table name and column name, creating an empty data set, and then we have this command called read SQL. Very similar pattern with a slightly different signature. And let's go down, see some of these other inits. Let's do it this way, a little faster. Init with contents of an ASCII file. So we're reading the ASCII file. That's straightforward. We have one with an XML tree. Again, straightforward. A different version of the XML tree. Init with data, so we start off with data and name. A little bit different. Init from SQL. So this is what we're doing in our table or in our document. We're saying, hey, let's pass in the database pointer and index. So let's take a look at this real quick. So again, we're prepping SQL, and then we're getting our actual SQL that we're doing. So we're getting from data sets where the ID equals whatever we're passing in. That's not particularly great because there's no guarantee that this ID is going to be right, because we weren't looking for IDs, we were looking for counts. So this right here is likely a bug. May not show up very often, but it's probably a bug. Then we do a prepare, do a step, and we're expecting to see 6 columns: name, table name, column name, predicate, and comments. So we have to go through this process of converting the data we get back from the SQLite to convert those. So just to be clear, this is the string here is the column name. Based on the column name, it decides what to do. And then again, we get read SQL from database again. So this all sets the metadata, but this stuff is going to read the data. So let's jump there. I think I jumped to the wrong place. There we go. There's 2 variations on that. There's read SQL and read SQL from DB. I think the difference between these two, I would suspect, is that we're passing in the database versus this is probably pulling it from the document. There it is. If this code's pretty much the same, we could probably just go along and just tell it to have this called, read this one, and just pass in, instead of having to pass in the database rather than passing it or having 2 separate functions that do more or less the same thing. But if we look at this, this is actually, I'm not going to go into detail, but it's basically pulling data out of the database from a different table and hydrating the values that are stored by this type. This is kind of uncomfortable behavior. You know, the type really shouldn't be doing this. Somebody should be hydrating the type externally and rather than the type building up itself like this. So it's very awkward, and it makes it very, very tightly bound to SQLite. I mean, just look how many different emitters I had. I'd have to have a different one for each way I can build this type. That's not the greatest situation in the world. As you can imagine, this was more or less quite the battle to get working. So I had to spend a little bit of time trying to just organize the XR dataset type because it was just so mixed and jumbled. It was more of a reflection on how I built it over time rather than any kind of sensible organization. So I spent a lot of time just reorganizing things to group accessors together, statistic calculations, and all these methods together to make sense. There was a lot of changes to do. One of the important changes is I realized I didn't have an initer after all these initers that worked the way I really expected it to do. So I had to create one that said init with name, table name, column, predicate, comments, and data. If I'm creating these from the outside, where I'm hydrating it entirely from the outside, I need access to all the fields in the initer. So if we go down and notice here, remember I was talking about how read SQL and read SQL with the pointer was pretty much the same. I got rid of the one without the pointer. There's no reason to have the two. And then I went ahead and created my initer with the values. That's pretty straightforward. It's pretty easy to do. You just inject all the values and you set all the values. So the dataset values method or function is where we're actually reading the data for a particular dataset. Pass in the dataset and we're going to return an array of floats. So we know what the dataset is. We're going to get create a dataset query. So the dataset is a table. Again, it's not the same as XR dataset. Dataset is just a table representing what's in the database. And that is a table representable. And we have a data query set up for that. And we can just read all the data. And we can also then validate to some degree that our data is the correct thing. We just want to make sure that we are injecting only float value. So again, here's the data set, and here is just some minor things that have to be done there. And one of the things I've mentioned about third-party libraries that's kind of important to know is that they're all opinionated. And you can run into problems where if you're using a library that uses SQLite or uses the user defaults or whatever, that at some point they may be storing data differently than you expect, and it makes it hard to move to a different service to do the same thing. Here's an example where I made it surprisingly difficult on myself. So the comments in the application for a particular dataset is actually an attributed string. And those data are encoded as RTF data with a base64 encoding, which I did not realize because it's been 20 years. That was the case. And that raised problems because I didn't realize at first that I needed to write base64 encoded strings and read them. So this particular dataset table representable had to have the ability to code and decode those comments. So that was an unexpected pleasure there. In our in-memory store, ultimately, we needed two functions. We needed to retrieve the dataset, the table representable dataset, and then we need to be able to return an array of values for that dataset. So getting the datasets is easy. Again, we check to see if we have the SQLite. If we do, we can just then do our codable query ask for all the data sets. Boom, there you are. We just return them. A separate function then is dataset values, where we're passing in a single data set, and it will go through the process of pulling those data out of the source table. So they're two different things. And one thing we're trying to do in the in-memory store is limit its knowledge of types outside of the types that are associated with the memory store. So we don't want to have XC dataset here, really. We don't want it here at all, if we can avoid it. So we should try just to have only types associated with the in-memory store. We'll let the document model handle converting it to something else. So if we go to the document model, then we can have XR datasets. Eventually, we want to make our broader application dataset something different. But for right now, this is what we have to use. So for getting down here, when we open a file, whenever we open a file, we have to get our datasets right away. So we're getting our data tables and then our datasets now when we open the file. So let's take a look at that. So what we're doing here is we're getting our datasets and values. So we can ask the in-memory store, give me all the datasets. But those aren't fully hydrated because they also need the data, because we can't fully hydrate the XR dataset with just the dataset. So we're going to loop through all of these that we get back and try to get the value. So we have this tuple of datasets and values. So we have to do a little bit of extra work. So we're going to map these things with datasets and values and convert it to a data object. Whatever reason I originally thought of doing this, I did it as a mutable data inside the XR dataset. I'm going to keep it that way because if I decide to, I can have a lot of the math being done by metal if I so choose. So I'm going to leave it that way for now. So we still have to create a data set out of all the values we get back from the database. And then we can then hydrate the XR dataset and return it. Since we're mapping, it will go through each one and do the same thing. Now this did create a lot of problems. Like I said, I discovered things weren't working. I had to write some tests, make some changes, but ultimately we managed to get this fixed and working. The last method we need to fix is retrieve text column name. Now, the purpose of this method is to give you possible names of columns that you could choose from if you're creating a data set. So you already have your table. It's got a list of potential column names to use to pull data out to create your data set. So we need a method to extract those names. But we also limit it to specific column types. So SQLite, you can get a column name and you can get sort of the affinity of the column type. Is it a number? Is it a nullable value? Is it a blob? That sort of thing. Let's take a look at the original method. Here we are, retrieve non-text columns. Looks a lot like everything we've been seeing up till now. It has the setup, it has the SQL, it has the error check, and then it has the SQLite step. And then finalize, and then setting an array and returning it. There are a few weird things about this. For one, to be able to get a list like this, we actually have to do a select. I limited it to one here because I only want one result. To be honest, I don't really want the one result, but you have to have this for being able to get the column information. So we do a step, and it's only going to do it once because we have this limit up here, one. We don't necessarily need that, but we can use it. So if we get to here and we get a row, we want to then find out how many columns that we have, and then we want to loop through each of those columns. We want to ask SQLite, what is the column type? What is the column name? If that type is a valid type, then we add that column name to the columns. It's pretty straightforward, realistically. It's probably one of the easier methods to modify. But it does have magic numbers. These numbers are not clear what they are. They're column types by number. If you look up here, the column type is also defined by number. If you go to SQLite, documentation, or at least the headers, you'll find that these are very specific SQLite values. So for future reference, we don't really want to use flat numbers like that. We want to use what SQLite tells us those numbers are. Let's move this somewhere else. So here we are inside the in-memory store file. We have this simple function here, value column names for string, which is the table string, and it returns an array of strings. Pretty much what we were asking for before. First, we create an array of what column types are available. So I created this column affinity type just for convenience. We could just use straightforward use SQLite values, but I kind of like using these separately. For some reason, I'm not jumping to that definition. Let's go down to here, and you can see what the values are. So here we have 1 as an integer, 2 as a float, and so on. Now, if you look back at the original code, we accepted null. I'm not sure exactly if we want to accept null. So right now, I'm just going to do integers and floats. So that's what we have here. We get the store. We validate the store, make sure it's something that it's actually valid. Then we get the columns because we have a SQLite column thing for, or we have some code here to get columns, and we just made that one for this particular thing. So I have this function in the interface that basically says columns for SQLite and table. So you give the table name, give the SQLite pointer, and it'll return an array of column informations. So basically it goes through and does the same thing that method in the document. So we get all the columns. And then we just return a compact map. If it doesn't have the right affinity, it will reject it. But if it does, it will return that column name. Otherwise, returns no, and it just doesn't get added to the compact map. So the document model then has a very simple function that says, hey, give me all the possible column names. And it just calls into the in-memory store and says, hey, give me that list of names. And then we end up back to where we were. And we're now just calling into the document model, hey, give me that list of names. And if there's an error, present the error. Otherwise, return that array of columns. So what that means at this point is that we've now removed any direct SQLite calls from the document. And that suddenly is making our life a little better. But if you look onto the right here, all these yellow spots are still places where we're still using the in-memory store pointer to do other things. Like we saw in the XR dataset, where we were passing in the pointer so it could hydrate itself, which is kind of a weird pattern. We're using that pattern all over the place. So save to SQLite, all sorts of places where we're doing it. In part, this is, again, that same pattern of having things hydrate themselves, which is bad, but it's also a symptom of having things going on in the document that probably should not be there. So next time, we're going to start a little bit of a different thing. We're going to jump in and try to identify which methods in this document class could be moved elsewhere. There's a lot here, and we should really consider moving this stuff away. So we're going to go through, take a look at some functions next time, and trying to figure out, can we move it somewhere else? If we can, where do we move it? I hope you enjoyed this episode. It was a little fast because the number of changes were far bigger than I was anticipating. Again, because all this tight integration made it very difficult. And it would probably take a few hours to go through all the changes. But take a look at the source code and see what I changed and why I changed it. I'm not perfect here. It was more or less a first pass. A lot of this stuff I'm not sure is going to stay there for long, but the idea is to keep it working over time. So feel free to add questions and comments in the comments section, and keep on coding. My name's Tom. See you next time.